Hey everyone, welcome to week 1 linear equations. This is a recording for Algebra 2A Live. Let's get started with things. So for week 1, as you're working through this class, I want you to make sure you're checking in on our CK12 textbook, going through all the sections. There's 7 of them. Take a look over this recorded video, take notes, look over the examples, make sure you're understanding things. You need to work on the week 1 paper pencil problems and all the other assignments for this week. Also the week 1 test in Canvas. You do get 2 attempts on each test in Canvas, so you have opportunities to revise your work and work on stuff that way. Okay, your objectives for week 1. What are we working on? Well, here's some things I want you to be able to do. If I give you 2 points, can you find the slope of a line? If I give you 2 points, can you write a linear equation in slope-intercept form? If I give you 2 points, can you write a linear equation in standard form? I want you to understand how slopes work between parallel lines and perpendicular lines, and then be able to solve problems using linear equations and graphs. We're going to go over all these concepts, talk through them, do some example problems, and hopefully help you understand it. A lot of this should be review, since you've already been through Algebra 1. I'm hoping it won't be too much for you guys. Okay, let's review slopes. Linear equations are equations that model a constant rate of change. They form lines because they're always growing by the same amount over and over again, or decreasing by the same amount over and over again. We call this constant rate of change the slope of the line. We have a formula here. If you remember, the slope of a line is related to y2 minus y1, all divided by x2 minus x1. If you forget what those are simply the values of 2 points. Right? If I have a point and another point, here's 2 points that I could graph in ordered form. All the 1s and 2s means is this is the first point, so we call it x1 and y1, and this is the second point, x2 and y2. So you got to have at least 2 points to find out how much you're changing along your y values and how much you're changing along your x values. Let's do an example of this. Here's a line down here. What is the slope of this line? I got some points on here for you guys. Let's calculate what the slope is. Now the nice thing is it doesn't matter what 2 points we use. We can just use any 2 points. So I'm going to go ahead and use this point right here, negative 2, 3.4, and this point right here, 4, negative 2.2. So there's my x1 value for my first point. There's my y1 value for my first point. There's my x2 value for my second point, and there's my y value, y2 for my second point. So if I want to find the slope of the line, I'm going to take the slope is going to equal negative 2.2. That's my second y value right here, minus the first y value, negative 3.4. I'm going to use parentheses to help me keep all my negative values straight. And I'm going to divide that by my change in x values. My second x value was 4, so I'm going to put 4 here, minus negative 2. All right, so what do these have now? Change pen colors. So if I do negative 2.2, minus a negative, that ends up becoming plus, so negative 2.2 plus 3.4, I end up with 1.2, and it's going to be positive. On the bottom, I have 4 minus negative 2, that ends up becoming 4 plus 2, that equals 6. And if I simplify that fraction, 1.2 divided by 6 just turns into 0.2. That is the slope of my line. And we can also see this on the graph as well. This 6 just represents going over 6 units. So I went over 1, 2, 3, 4, 5, 6 units to the right along my x values. But from there I also went up 1.2, so we go up 1 plus a little bit more, the 0.2. So you can see the change in x and y along your graph you can calculate the change in x or y by subtracting a couple x values and a couple y values. So my slope of this line is 0.2. It's growing by 0.2, and it's good because we can see that this line is increasing. It's sloping up. So I should have a positive slope. All right, moving on. So every linear equation, lines have slopes that increase or decrease at a steady constant rate. We also want to be able to represent the patterns we see in a linear equation with an actual equation. So here is y equals mx plus b. If you remember, that's what we call slope-intercept form. All linear equations can be written in this form. This value for m is just a parameter that represents the slope or the constant rate of change. Our value for b is a fixed point. It's the y-intercept. So for an equation, I need to know at least one point that line goes through and then how much it's increasing or decreasing based off that point. X and y are just my variables, right? They're representing what is changing. As I change my values for x, how does that affect my values for y? Right, let's write a slope-intercept form equation. Okay, so we got the same line. We already know the slope is 0.2. We calculated that previously. If I look over here, I can see the y-intercept is where it crosses the y-axis. So right here is my y-axis, the up and down vertical one, and it's crossing right at this value right here, at a value of 0, -3. So my y-intercept is at -3. And if I know the slope, and if I know the y-intercept, then I can write an equation. Y is equal to 0.2 times whatever x value minus 3. That is an equation that shows the same information as this line. We could even test this out, right? Let's take this point over here. When x is 4, this point on the line is saying when x is 4, y has to be -2.2. That's what my graph is showing. That point is right on the line, and my equation should show the same thing. So let's actually do that. If I put -2.2 in for y, does it actually equal 0.2 times x, which is 4, minus 3? Well, 0.2 times 4 is 0.8, and 0.8 minus 3 does equal -2.2. So we just actually showed that our equation works by putting in the coordinates, x and y values of one point. And yeah, it does work. And it would work out for any one of these points. All right, let's talk about standard form. So we can write every linear equation in slope-intercept form. We can also do the same thing in standard form. Standard form is just another way to rearrange it to write an equation. And it's helpful, especially as we get into systems of equations, to be able to go back and forth with the two different forms. Standard form uses this value a times x plus b times y equals some value c. A, b, and c all have to be integers, which means they have to be whole numbers, but they can be positive or negative, except a has to be positive as well. So what that means is we don't want any fractions, we don't want any decimals, we have to have x term first and then the y term, and a can't be a negative value. So let's play around a little bit with standard form. Okay, let's take a look at this problem here. If a line goes through points -2, 8, and 6, 10, what is the equation of the line in standard form? Well, we've got a lot of steps to go through here. The first thing I want to do is find the slope of a line. If I'm writing a linear equation, I always need the slope. So here's my x1 value, there's my y1 value for my first point. Here's the x value for the second point and the y value for the second point. Now we can start using my slope formula. I'm going from 8 to 10, so that's a change of 2, an increase of 2, so going 8 up to 10. And then from my x values, if I subtract 6 minus negative 2, that turns into 6 plus 2, that's going to be a change of 8, and 2 over 8 reduces down to 1/4. So in this linear equation, I want to have a slope of 1/4. It's growing a little bit, but not too much. All right, now, before we get into standard form, I think it's easier to first write it into slope-intercept form. So I'm going to change colors here. Let's do blue. That means I need y equals mx plus b. I'm going to put in my slope for m. And I'm going to use this point right here, 6 and 10, to solve for b. All right, so let's put 10 in for y, because that's the y value. 10 equals a slope of 1/4 for m times 6. If I put 10 in for y, then x has to be 6, plus our unknown value b. And we can solve for b now. 6 times 1/4 is 6/4, or it's easier just to rewrite it as a decimal. In this case, is exactly 1.5. So 10 equals 1.5 plus b. And so my y-intercept, if I subtract 1.5 from both sides, my y-intercept has to be 8.5. And we have the equation y equals a slope of 1/4 times x plus 8.5. Now I could change the 1/4 to 0.25 and leave it there, fractions and decimals. It works okay. But there we go. So we found the slope first. Now we have it in slope-intercept form. Now let's go through the work and turn this thing into standard form. So we get a nice magenta. Oh yeah, that's a good color. Okay, so standard form. Remember standard form, everything needed to be whole numbers, no fractions or decimals. So the first thing I want to do is look at what can I multiply both sides to make sure everything is an integer. Well, I have 1/4. That means it's this dividing by 4. So I'm going to look at multiplying everything by 4. I know it'll work for the 8.5 because 8.5 times 4 will turn into an integer as well. So let's multiply everything on both sides by 4. And what do we have? We now got 4 times y. 4y equals 4 times 1/4 just turns into 1, so I just have 1x, plus 8.5 times 4 is going to be 34. All right, all integers. I like that. Now I need to have x and y on the same side, so I'm going to subtract an x from both sides and move it over there on the left. So we've got negative x plus 4y equals 34. I'm almost done. I'm getting really close. However, remember my value for a in the beginning, it has to be a positive whole number. So I can't have negative x. So I'm going to multiply everything again on both sides, but I'm going to multiply by -1 on each term on both sides. So there's -1 multiplying. And that'll give me positive x plus -4y equals -34. And there, we have turned our equation. Our linear equation is now in standard form. There we go. Boom, done. Okay, let's touch a little bit on parallel lines and perpendicular lines. Parallel lines have the same slope. It's pretty easy, right? Parallel lines, if we draw a picture, it just means it's two lines that are going side by side, and they never intersect. So that means they grow at the same amount, the same rate of change when they increase. Contrast that with perpendicular lines. Perpendicular lines have negative reciprocal slopes. And if we try and visualize this, there's one line, a line perpendicular to it means, that's a really shaky line, it means it forms a 90-degree angle, right? So you can clearly see one line has to have a positive slope. But to be perpendicular, if one line has a positive slope, one line has to have a negative slope. They both can't be negative and they both can't be positive. That's why we call them negative reciprocals, right? One's positive, one's negative. Now the reciprocals, because if one goes over, say over 3 up 2, that's going to have a positive slope of 2/3, right? Over 3 up 2. But the other one is going to go down 3 over 2. So it's got a slope of negative 3 over 2. And now you can see why we use the word reciprocal. Reciprocal in a fraction means they flip over. 2 over 3, 3 over 2. Those are reciprocals of each other. So if you're doing perpendicular lines, and if you know one slope, you can easily find the other slope. Let's take a look at a practical geometry aspect of this. This picture is kind of skewed because it's been stretched a little bit, but based on the points and the coordinates, does this line form a square? So again, we have to think about the definition of a square means all lines have 90 degree, all corners have 90-degree angles. So is this a 90-degree angle? Is that a 90-degree angle? 90 and 90. Another way to say a 90-degree angle is they're perpendicular. So if I want to show that they're perpendicular, I want to find the slopes of all these lines. And using the slope, I can quickly show if things are parallel or perpendicular. Okay, so let's call this line A, this line B, line C, and line D. We're going to find the slope of each of them. So for A, I'm using these 2 points right here. I'm going from -2, -1 to 0, 3. So let's find the slope there. I'm going to do 3 minus -1. It's going to give me 4. And then 0 minus -2 is going to give me 2. So it looks like the slope right there is 2. Now let's do B using those 2 points. So I'm going to do 1 minus 1 minus 3, subtracting my y values. Then I'm going to do 4 minus 0, subtract my x values. And we get -2 over 4, which is -1/2. Now just comparing those two slopes, 2, I can express 2 as 2 over 1, right? 2 over 1 is the reciprocal of 1 over 2. 2 is positive, -1/2 is negative. So we've just shown that we have perpendicular lines right there. A and B are perpendicular to each other based on what we got for their slopes. All right, let's keep going. Let's do C. So for point C, I'm going to do -3 minus 1. Subtract my y values, and I'm going to do 2 minus 4. So we get -4 over -2, which ends up equaling +2 again. And I can see that 2 and lines C and B have to be perpendicular because they're negative reciprocals as well. And I've just shown that lines A and C are parallel. They have the same slope. So let's do the last one. Let's figure out D here. So D, I'm going to take -3 minus -1. And then I'm going to do 2 minus -2. Make sure you keep all your negatives straight. That would be an easy way to mess up. -3 minus -1 turns into -3 plus 1. So that gives me -2. 2 minus -2 turns into 2 plus 2. So it's +4. That simplifies down to -1/2. And B and D are parallel. They have the same slope. But C and D are perpendicular. So we just showed all 4 corners are perpendicular or 90 degrees. Now to really form it's a square, we need to show that they're all the same length. So we've actually only shown so far that it's a rectangle. But for our purposes, that's pretty good. We wanted to understand lines, slopes, parallel, perpendicular, and determining all of that. Okay, last one. I want to do a little bit of problem solving, taking a problem and figuring out how to translate it into the right algebraic linear equation. So here we go. At a football game, Brian is selling concessions. He sells soda for $2 a piece and popcorn for $3 per bag. At the end of the night, he has sold out of soda and he's made a total of $264. If he sold 60 sodas, how many bags of popcorn did he sell? All right, so in any algebra, the first place you want to start is trying to figure out some variables. What is changing? Well, he made $264. That's not a changing amount. But throughout the whole night, what is changing is the number of sodas he sold and the number of popcorns he sold. In fact, that's even our question. How many bags of popcorn? We're trying to solve for P. We're popcorn. That means we don't know what it is. So let's let P represent how many bags of popcorn he sold. Usually that question at the end helps define a variable. And for the initial start, let's the S represent the number, let's see, the pieces of soda, right? Because we're kind of defined it in pieces. Really cups of soda. Probably should write cups. Now we know it's 60, but I'm just going to start a general equation. So now let's put it together. I know when I'm selling popcorn and soda, I'm making money. We're making $2 for each soda, so 2 times S. But I make $3 for every bag of popcorn, P. I add all that money together, it's getting pushed in my cash register, and we made a total of $264. We've now just took this whole problem and we've translated it into an algebraic equation. That's the power of algebra right there, trying to represent situations using symbols, math, and equations. All right, but now we can use some stuff we know, right? So we know these sold 60 sodas, so S actually equals 60. So let's substitute 60 in for the number of sodas. And then we can use our problem solving skills to figure out, well, how many bags of popcorn did he sell? There, we're going to solve for P. All right, 2 times 60 is 120. I can do that math. Plus 3 times P equals 264. Again, I like making meaning of it. So that means he made $120 off his 60 sodas. But I'm not worried about that. I'm worried about just the popcorn. So let's subtract off the $120 he made from the total of 264. And we see that $3 for each popcorn must have totaled up to 144. All right, so if it's $3 for each bag of popcorn and it totaled up to $144, let's divide both sides by 3 and see how many it did. So P has to equal 144 divided by 3 is going to be 48. So he sold 48 bags of popcorn. All right, there you go. Using linear equations to understand and solve word problems. All right, so there we go. We've just completed our week 1 video. Make sure you read the sections in our CK12 textbook. You can review this video as you need. Use the video in the textbook to help you work on the paper pencil problems and the week 1 test. If you need any help, come to an online classroom or let me know. I'd love to work with you. And have a great first week.